Okay, so I welcome one more lecture session on the topic that is called as digital signal processing. On the particular topic, basically linear systems versus non-linear systems. So as I told you that linear systems and non-linear systems is basically based on the principle of superposition. So it is basically based on the principle of superposition law, right? So superposition principle. So it basically based on the principle of superposition. So what it basically says that a system is said to be linear if and only if and only if the transformation operator that is basically happening or basically taken on the summation of a1 x1 of n plus a2 x2 of n should be equals to individual transformation operators on the individual signals, that is a1 x1 of n plus the transformation operator that is equals to a2 x2 of n, right? So this is the basic the criteria that needs to be satisfied to take the decision whether the system is stable, linear systems or non-linear system. So a system is said to be linear if and only if the transformation operators basically done on the summation of the individual two signals or discrete time sequences it should be equals to the individual transformations happen on the individual sequences. Okay, so this I can basically say is that this may be equals to y1 of n and this is equals to your y2 of n, right? So that means if the transformation operator, that is this is nothing but equals to y3 of n, and if this is matches with the summation of this, then I can basically say that the system is linear in nature. So to have a more precise insight regarding this particular topic, or to have a very good knowledge regarding this particular concept of digital signal processing, let us go for certain problems so that it will give you a clear-cut foundation on what a linear system is, what a non-linear system is. So in the previous classes we have seen some of the systems regarding like time invariant system and time variant system. We have seen your stable systems and unstable systems, but linear systems and non-linear systems are very much essential when you will going to study some of this like systems which basically a combo of linear as well as time variant or invariant systems. So for that type of systems you have to check the two conditions simultaneously. You have to check the condition for linearity or non-linearity, simultaneously you have to check the time variant property as well as it is satisfying time invariant property. So we need to see those things which we're going to cover up in upcoming classes, okay, after covering convolution. Next, let us take certain examples. Like first problem is that we need to determine determine if the system described by the following input output relationship. So I can say input and output relationship are linear or non-linear. So that means this is the problem that is basically asking to check whether it is a linear system or non-linear system. So we need to use the property that we have studied just now. Now the mathematical property, linear or non-linear. So some of the problems that we'll see is that the first problem that we have to see is yn is equals to n of x of n. So this is the first problem that is given to check whether the system is linear or non-linear. Second problem that we're going to see is that yn is equals to x of n square. Third problem that we'll see is equals to yn is equals to x square n, right? And the fourth problem we're going to see is nothing but equals to yn is equals to a times of x of n plus b. That means there is one constant that is added. And in the fifth problem we're going to see is yn is equals to an exponential signal that is called as ex to the power n. So these are the 5 problems that we'll see of different flavors, and we're going to see whether the systems are linear systems or they are called as your non-linear systems. So first problem that we're going to see is yn is equals to n times of x of n. In the second problem we're going to see yn is equals to x of n square, and yn is equals, third problem we're going to see yn is equals to x square of n. Fourth problem we're going to see is yn is equals to axn plus b, and fifth problem we're going to see is e to the power x of n. So going to the first problem and solving it. So first problem, basically yn is equals to n times of x of n. So this is the first problem. So we need to solve this first problem. Yn is equals to n of x of n. So as I have told you that for linearity condition, we have the condition that the transformation operator that is happening on a1 of x1 of n plus a2 of x2 of n should be equals to the individual transformation operator happening on the individual signals. That is, this is a1 is getting multiplied, that is a1 of x1 of n. Similarly, a1 of x1 of n plus the transformation operator that is equals to a2 of x2 of n. So these three signals I basically named it as, this is I'm basically taking it as y3 of n, and this basically taken it as y1 of n, and this basically taken it as y2 of n, right? So first we need to find out the individual x1 of n and x2 of n, then only we will be able to find out the value of y1 of n and y2 of n. Then we'll be able to find out y3 of n by taking the overall transformation operator happening on the combination of the two sequences. So first we need to find out that y1 of n, that is implies the solution is starting from here. The y1 of n is nothing but equals to the transformation that is happening on a1 x1 of n. So it is equals to the transformation happening on a1 x1 of n will be nothing but equals to your n value will not going to be changed because the operation is happening on x1 of n. So n value will be remain as it is, then it will be written as your x of n. So this will be basically written it as, so this is basically written it as like a1 n of x1 of n. So here if you can take the a1 n value, you can take the a1 n value, you can't take also the a1 n value. So if I'm removing this a1 and a2, it's not a problem, because here I'm basically considering, let us a1 is equals to a2 should be equals to 1. If I'll take this condition, then a1 a2 will be vanished over there. So I can choose these conditions. This will not affect me or affect while solving the problem for checking the linearity as well as non-linearity. So a1 and a2 is basically considered as 1. So a1 is 1 and a2 a1 is 1. That means your a1 value is equals to 1 and a2 value is equals to 1. So that means a1 is equals to a2. Then I can simply say that this is the transformation operator happening on n of x1 of n. So that is nothing but equals to n of x1 of n. That is equals to my y1 of n. Right. So I initially found out what is the value of y1 of n, taking a1 equals to a2 equals to 1. So here this is the basic condition for linearity checking. That means we have to check the system to be linear and non-linear by taking the transformation operator on the combination of two discrete time sequences, and it should be equals to the combination of the individual transformations happening on the individual sequences. If we take the summation, it should match with the sum of the sequences along with the transformation, right? Next, I need to find out the value of y2 of n. So y2 of n should be equals to the transformation operator happening on a2 of x2 of n, and that is nothing but equals to the transformation happening on a2 is equals to 1. So I can say 1 into n times of x2 of n. So that is equals to my value is coming as n of x2 of n, and which is nothing but equals to my y2 of n. So y2 of n value is equals to n times of x2 of n. Right now, what I'm going to do now, I got the value of y1 n, that came as n of x1 of n. Similarly, I got y2 of n, that came as n times of x2 of n. Now it's time to find out the value of y3 of n. What is that? And whether this y3n is equals to the sum of this y1 and y2n. If y3 of n is equals to your y1 of n plus y2 of n, then I can say that this is a linear system. Okay, so this is a linear system if this condition matches, right? If this condition matches, then I can say that system is linear. Otherwise, if this condition, if this y3 of n, if it is not equals to your y1 of n plus your y2 of n, then I can say that system is completely non-linear in nature. So this is regarding non-linearity. So this is non-linear. So this is a non-linear system. So I already found out what is the value of y1 of n. So I got y1 of n value is equals to n times of x1 of n. y2n of value also I got, that is n times of x2 of n. Now it's time to find out the value of y3 of n. So y3 of n, so I can say y3 of n is equals to the transformation operator happening on a1 of x1 of n plus a2 of x2 of n, right? This is actually y3 of n, right? y3 of n is equals to transformation operator happening on the combination of the two sequences, right? Now if I am going to write that, now this is nothing but equals to y3 of n should be equals to, y3 of n is nothing but equals to the y3 of n is nothing but equals to this is the transformation operator that is happening, and this is nothing but a1 of n of x1 of n plus a2 of n of x2 of n. Then what I got, that is y3 of n should be equals to this. This I can basically say that if this, you can say that this is if a1 and a2, if a1 is equals to a2 should be equals to 1, then I can say that this particular value will come as n times of x1 of n, and this basically comes as n times of x2 of n. Now y3n, now the value of y3n that I got is nothing but equals to n times of x1 of n, and it is equals to n times of x2 of n. Now similarly, if I do the individual summation of y1n and y2n, if I do the summation, y1 of n plus y2 of n is also giving me the same result. That means n times of x1 of n plus n times of x2 of n. So these two results are equal. So what I am getting, that these two results are coming at same. So what I am proving over here, so it proves that y3 of n is equals to my y1 of n plus my value y2 of n. So that means this is a linear system. This is a linear system where x of n is equals to n times of x of n. So this is a linear system. So just now I proved that this is a linear system. So in a very simple way I can prove by taking the mathematical condition that whether a system is a linear or a non-linear systems with different type of complex problems which will be given. And next, going to the second problem, that is equals to yn. This is the second problem I am solving. So yn is equals to x times of n square, right? So yn is equals to x times of n square, right? So what I will going to do, so same thing I will going to apply. So applying the property, so applying the condition, I can say, I will not say it as a property, but I bet the better word will be condition. That is nothing but equals to, that implies it is nothing but the transformation operator that is happening on a1 of x1 of n plus a2 of x2 of n should be equals to the individual transformations on the individual sequences. Okay, now what I'm going to do, first I need to find out, so this is my value, so this is what I got, this is called as my y3 of n, right? And this is my y1 of n, and this is my y2 of n. So same procedure that we have followed, for the first problem, same thing will be followed in the second problem too. So I need to go for y1 of n should be nothing but equals to the individual transformation happening, that is a1 of x1 of n. So here I'm basically taken it as a1 is equals to a2, that is equals to 1. So I can say that simply, I can say that this is the transformation happening on the signal, that is x1 of n, right? But this you have to take initially, because this is the mathematical property for checking linearity as well as non-linearity property of the system. So if I'll say that y1 of n, so I can say that y1 of n is equals to my x1 times of n square, right? So y1 of n is equals to x1 times of n square. Similarly, if I take the y2 of n value, this will also give me the same different value for x2n also, that is x2 of n whole square, right? So the two outputs I have obtained, that is y1n is equals to, this is 1 and this is 2, if I can say. So y1n is equals to x1n of whole square, and y2n is equals to x2n of whole square. Now it's time to find out the value of y3n. So I need to find out the value of y3n, right? So I have already the value of y1 with me, I have already the value of y2 with me. Then I need to find out the value of y3n. Now y3n is equals to, what it basically says, that it is the transformation operator that is happening on the combination of the two sequences, that is plus a2 of x2 of n right? So this is my y3 of n. So this y3 of n can say that this can be written as a1 and a2 will be equals to 1, then x1 of n will be nothing but equals to the answer I will going to get. The answer I will going to get is nothing but equals to how much? The answer I will going to get is nothing but equals to how much? Okay, the answer I got, the answer of if I'm going to get is how much? So the answer if I'm going to get, that is equals to how much? So this is basically I'm getting it as a1. This is basically getting it as a1 x1 of n square plus a2 x2 of n square, right? So this is equals to y3 of n, right? So this is also equals to y3 of n. Now if I'm going to say that y1 of n I got initially equals to a1 times of x1 whole square, and if I get y2 of n that I got is nothing but equals to a2 times of x2n whole square. Here in the previous time what I've taken, if I'll take a1 is equals to a2 equals to 1, then the answer will come it as y1 of n should be equals to y1 of n should be equals to my value x of n of square, x1 of n of square. Similarly, y2 of n value will come it as this is equals to x2 of n of square. Understood? X2 of n of square, x2 of n of square. So that means if I take a1 is equals to a2 equals to 1, or if I want to keep the value of a1 and a2, I can easily check it out. So it will not going to hamper. Okay, if I'll take a1 and a2, if I'll keep, or otherwise I'll not keep, I can easily check the linearity condition and non-linearity condition. So this is the value that I got. This is the value that I got for y3 of n. And if I'm going to sum this, if I'm going to sum this, and if an a1 and a2 equals to 1, then I can say that this system is also linear. This system is also a linear system. Is also a linear system. So so this will going to give you a very good fundamental if you'll solve a lot of problems. Going to the third type of problem is nothing but equals to my yn. Yn is equals to x times of x square of n. This is the third problem, right? So same thing I'm going to put you. So we already know the mathematical property of this. So this is the, you always going to use this property, that is nothing but equals to a1 of x1 of n plus a2 of x2 of n should be equals to the individual transformations on the individual discrete time sequences, right? So this is equals to t times of a2 of x2 of n, right? Now if I'll say, then here I need to, this is y3 of n, and this is the value which I got. This is my y1 of n, and this is my y2 of n, right? So this is my y1 of n, this is my y2 of n. So similarly, first finding out the value of y1 of n. So I need to find out the value of y1 of n. So y1 of n is nothing but equals to, y1 of n is equals to nothing but x1 whole square of n. Directly I can get. So as we have already know the property of linearity, so no need to write this transformation. But when you need to write in the exam, you need to first write the condition, mathematical condition for linearity and non-linearity by taking this particular mathematical property, right? So now if I'll take about y2 of n, so this is also going to give me the result in x2 square of n, right? So this is the answer if I'm getting. Now if I'm able to find out what is the value of y3 of n, now y3 of n is nothing but equals to the transformation happening on x, so a1 x1 of n plus A2 x2 of n. Right, so this is the transformation happening. Understood? So this is the transformation happening on the signal. Right, so some of the sequences will be taken, then only the transformation will be there. Now what it will going to give me? Right, so this I can say that the transformation is nothing but is square. Right, the transformation is nothing but this t transformation is nothing but the square is happening. So what I'm going to do, I can simply write that y3 of n is equals to a1 x1 of n, plus a2 x2 of n whole square. Right, this is the y3 of n is nothing but y3 of n is nothing but equals to how much? It is equals to your x3 of n whole square. So that means y3 of n is, that means the overall signal will going to be squared. So this is just written to give you an understanding that why I have taken it as directly. Right, so this you can keep it. Now if I'm going to solve this, this y3 of n is equals to a1 square x1, this is a plus b whole square, this is a1 square x1 square plus a2 square x2 square plus 2 times of a1 into a2 into x1 n into x2n. Right, so if y3n is some, in y3n that is 2 extra terms are coming. So 2 extra terms are coming as 2a1 a2 x1n into x2n. If a1 is equal, a1 a2 will be equals to 1, then it will be 2 times of x1n into x2n. So this is the extra term. So this is the extra term getting. So this is the extra term. So that means I can say that y3n is not equals to your y1n plus y2 of n. Right, that means, so I can say that this is a non-linear system. So this is a non-linear system. Right, so this is a non-linear system. Okay, so this is a non-linear system. Now I hope in these 2-3 examples that has been solved, we're going to give definitely create a very good profound concept on this particular type of system that is called as a linear or non-linear system. Now the other problem, that is 4 is equals to y of n is equals to a times of x of n plus b, and the fifth problem which is given that y of n is nothing but equals to exponential value to the power x of n. Right, so these two condition I am leaving to you. You need to solve it in your copy, and you will need to find out whether the systems are linear systems. These two problems are for assignment. Okay, so you need to see that whether the system is linear or non-linear systems, and you need to show to me later. Okay, now today we're going to learn about a new kind of system which is also the part of discrete time system, is your causal versus non-causal system. So this is called as my causal versus non-causal system. Okay, so what do you mean, how we can say that the system is basically a causal system, where whether it is a system is a non-causal system? So how we will basically going to find out. Now Coming to the definition of causality as well as non-causality, the first way to say that a system is said to be causal. A system is said to be causal if the output of the system at any time n, that is anytime n, the output is basically, that is your y of n. This is basically the output, right? So that means a system is said to be causal if the output of the system at any time n, that is yn, depends on present and past inputs, depend on present and past inputs. Present and past inputs, that is, some of the examples I'm giving over here is x of n, comma x of n minus 1. So this is one past input, that is called as a delayed input. X of n minus 2, of x of n minus m, if I'm going. So these are my past inputs. That means it will depend on the present as well as it will be depend on the past. But depends on present and past input, but does not depend on future inputs. But doesn't depend on future inputs. So then I can say that my system is causal, otherwise it is a non-causal system, right? Then only I can say that system is a causal system, otherwise it is a non-causal system. So what I can say, for causality or for causal system, the condition is that it needs to satisfy that the causal system should depend on present input, as well it is depend on the past inputs, but it doesn't depend on the future inputs. Future inputs are like x of n plus 1, x of n plus 3. These are my advanced inputs, which are called as my future inputs. So now we're going to see some of the conditions, checking the condition whether the system is a causal system or a non-causal system. So let us take one example, like the first example is A. If I'll say y of n is equals to x of n minus x of n minus 1, then B question is coming as yn is equals to summation of k equals to minus infinity to plus infinity x of k. C value is coming it as y3 of y of n is equals to a times of x of n. Similarly, D question is yn is equals to x of y of n is equals to x of n plus x of 3 times of, that means scaling is that is a constant has been multiplied with 3 times of x of n plus 4, and the fifth E problem is yn is equals to x of n square. Then yn f problem is, now okay, we'll not go into the upcoming problems, we're going to see first directly over here. So here you can see that this is depend on the present input as well it is depend on the past input. So I can say this system is a causal system. So this is a causal system, right? So directly I can check that this is a causal system because depend on the present and the past input. But where I will talk about this is depending on the present. Okay, so like what I can say, so in this particular part, if I'm going to say in this particular part, this is equals to k equals to minus infinity to plus infinity, then I can say that this is a non-causal systems. Why? Because it is coming from minus infinity. That means from minus infinity means this is basically the past. This is basically the future. So I can say that in past it is depending, then present will be there also, the present value will come, but the future input will also come. So this is a non-causal system. Then coming to this part, this is also called as a causal system. So this is also a causal system. Now in this part, this is a non-causal system because this is depending on the present, but also there is a future input is there. So this is a non-causal. So this is causal because only the present input is there. If that they scale this multiplication with a constant value doesn't affect the causality as well as non-causality of the system, right? Now when I will see, then when I will see about this value, if I'll say x of n square. Now coming to this particular problem, these problems you can clearly see and you can easily find out that. Now coming to this problem, that is y of n is equals to my x of n whole square. Now if I'll take y of 0 is equals to my x times of 0, y of 1 is nothing but equals to my x times of 1 square will be equals to 1, right? Now y of 2 should be equals to x of 4 because it will be 2 square. Similarly, if I'll see y of 3, that is equals to my x of 9. So in causality, it basically says that y of 0 should be equals to my x of 0, or it will depend on the past value, or it will be depend on x of minus 1. Then I can say that system is causal. But if y of 0 is going to match, is going to be coming as y is equals to y of 3, then I can say that this is a non-causal system because this is an advanced output. This is the future value. This is a non-causal system. So okay, so this is, so in this particular problem, if I can say that in this particular problem, I can see that in some cases is depending on the present value, but sometimes the output depends on the past value of the inputs. So this is a non-causal system. So this is a non-causal system. Then second thing is that if I'll go to a one more problem, and if I'll say that yn is equals to my x times of minus of n, then I can say that what will happen? What will happen? If I'll see, similarly, if I'll put yn is equals to 0, then it is coming as x of minus 1. Similarly, you can say n is y is equals to 1, then I can say it will be x of this will be it will be equals to x of 0, because then y of 1 should be equals to x of minus 1. Doesn't matter because it is the past value, it will may come as causal, but we'll see some of, you will take some more like hit and trial techniques, so that we'll see whether it is causal or not, because taking some few values will not help us to find out the causality and non-causality, because you have to go for some hit and trial again. Then y of 2 is equal to nothing but x of minus 2. Again, it is depending on the present. But what will happen if I'll write y of minus 2 is equals to, this is a past, right, past input. Then if I'll say to -2, nothing but minus of 2, then I can see that this is x of plus 2. So how a past value is depending on the future input. So this also depict that this is also a non-causal system. Okay, so this also implies this is also a non-causal system, right? Understood. So this is a non-causal system. So one of the assignment that I'm going to give you to find out whether it's a causal system or a non-causal system is y of n is equals to x times of 4 of n. You have to check whether this is a causal. Check whether causal or non-causal system. We have to find this. So this is the problem. So this is the problem which is given. So this is actually one assignment for you. So you need to check. So you need to check whether the system is causal and non-causal system. Okay. So this is today. This is for today's class. So we have read about the causality as well as non-causality. We've seen about the linear as well as non-linear system. We have seen around 6 to 7, 8 problems, and around 8 problems, 7 to 8 problems we have seen. So I hope it has given you a very good idea regarding this causal as well as non-causal systems. So in the next class we're going to cover up the last part of your discrete time system, that is called a stable as well as unstable system. So thank you so much. So I hope you have enjoyed this lecture session on linearity as well as non-linearity and causal and non-causal systems. We will have one more lecture sessions and recording sessions on stable as well as unstable systems. Have a happy learning at home.